Hey, for Notes 13, we're going to start talking about what we do when we have qualitative data that we want to analyze. So up to this point in the semester, we've really been focusing on quantitative data for the most part. So we've had like baby weights back in Notes 1. We had the heights of plants in our Darwin example. We had these numeric scores on that creativity assessment. Um, and all these things like that, where we're looking at numbers and we're interested in the population means of those. But what do we do if we've got qualitative or categorical data and we want to answer a question about the population that came from? So we're going to introduce a little bit of new notation here. And the first thing is, instead of talking about a population mean, which remember we wrote with that Greek letter mu, we're going to talk about population proportions. And we're just going to use the letter P to represent a population proportion. So because this is talking about a population, this would be considered a parameter. And sometimes you might see this written as pi, but we'll stick with P in this class. I just want to let you know that you could possibly see pi used for a population proportion in another class. Sample proportions, we're going to use this P with this little sort of caret symbol over the top. And so that's going to be our sample proportion. And we refer to this as P hat if we're talking about it. So this would be our statistic. So just like we had X bar as our sample mean, we've got P hat as our sample proportion. So one example, maybe P is the true or population proportion of all Elon students who have never left the US. Maybe P hat is some sample proportion of 100 randomly selected Elon students, and I want to know what proportion of them have never left the US. So what we've been doing this semester is we've been using sampling distributions, which remember tells us how often we would see certain statistics if we took a whole bunch of random samples. We've been using this idea to help us make confidence intervals, hypothesis tests, and things like that. And so we've done some examples where we like randomly generated or sampled data over and over, we calculated a test statistic, and then we repeated the process. And this process of generating this sampling distribution helped us understand like what's a typical thing that we would see, what's sort of an unusual thing that we would see. And we can do the same sort of thing with proportions. So we're going to do an example where we try to do that. So I've got an activity set up that is going to look at this population of cane toads. And cane toads are an invasive species where if they sort of are introduced into a habitat that they aren't native to, they can really wreak havoc on some of the native species and things like that. So let's say that we're a biologist and we want to study what proportion of this cane toad population that we've found is female. And we believe that that's going to help us understand how fast they'll reproduce and things like that. There's thousands and thousands of these cane toads, and so the biologist is not going to be able to capture all of them. Instead, they're going to take a random sample of 30, and they're going to use that to try and make inference about the entire population and decide what the population proportion is that are female. So the way that we're going to do this is on the next page, I've got a list of 60 different samples that I've taken from this population. And so that everybody can take their own sample and go through this process on their own, I want you to look at the minute hand when you do this activity. So when you get to this point, just jot down what time it is. And for example, if it's 12:17, you would go to the next page and you would find where it says XX17. So this would be 12:17, 5:17, whatever time. And if that was what time it was when you were doing this, your sample would have 7 out of the 30 cane toads being female. So when I originally did this set of notes, it was 3 for the minute hand. And so I'm going to go through this example using a sample that has 13 female cane toads and 17 male cane toads, because I've got 30 total in my sample. All right, so find your number, write it down, write down how many of your cane toads were female, and you're going to use this to answer some questions throughout this set of notes. So let me go back to the activity here, and the very first thing that I wanted to do was I wanted to write down how many of my cane toads were female, and we saw that for my sample, I got 13 out of 30. Since our goal is to understand what proportion or what percentage of the total population is female, it might help if I could calculate the proportion of cane toads in my sample that are female. So to calculate my sample proportion, all I'm going to do is I'm going to take my 13 female cane toads, I'm going to divide by my sample size, which was 30, and for me, my sample proportion was 0.433. All right, so you should do this for your sample right now. Write down how many you had that were female, divide by 30, and write out your sample proportion, and we'll use 3 decimal places for this. All right, and then I want you to think about a couple questions. So the first one, let's say that this is, you're the biologist, you went out and gathered your 30 cane toads, and someone said, okay, we really want to understand these cane toads better. What's your best guess for the proportion of cane toads in the population that are female? And if you didn't have any other information, you'd say, well, I took a sample. This is the information I have about that population. So really, my best guess is just going to be whatever I saw in my sample. So my sample proportion is sort of a good, hopefully, guess for my population proportion. So for me, I would say, you know what? My guess is that 43.3% of the cane toad population is female. Now, someone might say, okay, well, how good of a guess is that? Do you think it's exactly right, close to right, not very close to right? And you might take some time to think about this. And we've seen enough things throughout the class where we would probably be able to say, you know what, it's probably not exactly right. Look at that table on the next page, and if everybody's taking samples and getting different numbers of female cane toads, then clearly we can't all get exactly the population proportion. So my guess probably isn't exactly right, but I'm hoping that it's sort of close to right. And this is something that we're going to investigate throughout this section of notes. So even though my guess isn't exactly right, hopefully it's at least giving me some information that can help me make a more informed decision. All right? So if you haven't done your own sample yet, make sure you take a few minutes to do that and you calculate your sample proportion. You'll get this from this table here. And then in our next section of Notes 13, we'll answer some questions related to what different people might see when they go through this same process.